I think solar is really the future, and it's absolutely taking off. And most new energy is a solar installation, and we're only going to amplify that. If you can get rid of the nighttime thing, that's really the only thing holding it back.
You're at Ben Nowack, founder of Reflect Orbital. Thanks for joining us.
Yeah, thank you.
So, your company, satellites, solar energy. I have a 10-year-old son. He would love this. He loves space. He loves science. Explain to me what you guys do as if I'm a 10-year-old.
Yeah, we are putting mirrors in space to reflect sunlight onto solar farms after dark. So there's a shadow behind the Earth. Sunlight hits on this side, doesn't hit on this side. Our satellites are right here, so we can reflect the sunlight right down to those shadow regions.
So it's like having like a giant mirror and pushing it down into the Earth.
Yeah, we capture the sunlight in space and bring it down to solar farms, large towns. If somebody needs some light, we can get it to them.
How big are these mirrors?
They're fairly small, just like about the size of a tennis court or something like that at first. Eventually, as we scale up, we launch more and more of them. And then you start making them larger and larger, and you kind of do it like that. But the way to think of it is we are trying to get as much area into space as possible, as much thin plastic reflective area into space as possible, and control it really well so we can get sunlight to the people who need it. And we're going to need a lot of it because there's actually a lot of people who want sunlight, especially when you start talking about gigantic billion-dollar solar farms.
Yes.
So we are going to put a lot of area into space.
So when they talk about tech, they always say hardware is hard. You're taking hardware and putting it in space. I can't even imagine how complex this is. Where did this idea come from?
Yeah, I've been thinking about energy for a really long time. I built like a small fusion reactor in high school.
Like nuclear fusion?
Yeah, the simple one. It didn't make energy, but it did fuse atoms together, deuterium atoms. So I made that in high school, made X-ray machines.
Where'd you get your material from?
The Nuclear Regulatory Commission approved it, and I bought it from Airgas.
Okay,
once you get the right approval, you can buy it, pretty locally.
All right, interesting. Okay, so you're obsessed with energy.
Yeah, obsessed with energy. Built a lot of RC planes, all kinds of engineering projects in school. I was trying to make antimatter for a little while as well. Realized that was a little crazy, so I kind of took the normal path. Went to SpaceX, got an internship there my freshman year of college.
How do you make antimatter?
You make fluorine-18 first, and that emits positrons, and positrons are antimatter. So you can use those, and I was going to try to harvest them and get some energy from that. But you need a linear accelerator in order to do that, and large arrays of power. So I remember I was going to Brigham and Women's Hospital and talking to radiologists there, looking at their linear accelerators, thinking how I was going to copy them, and they all told me to not do that. And I took their advice, and I'm kind of glad I did.
Okay, you and I had very different hobbies, so
yeah.
That is fine. What were you doing before you started Reflect Orbital?
I was working at a company called Zipline. They deliver blood and medical products with drones in like Rwanda, Ghana, places like that. And they're bringing that to the US. So I was working there when I had the idea for this. It started off, I realized that solar energy was leading the world for a long time. Like solar is a great way to make power. You get free energy from the sun. It's a lot better than fossil fuels in that way. Until the sun goes down, then it stops working. And then you need something else to come in and kind of fix it because you have that variability. And you can make the solar panels more efficient, but really the problem is you're not getting the fundamental resource, sunlight. And even if you have a solar panel in Germany, you move that to the Sahara Desert, it'll make 3 times more energy. That's just a huge difference because of the fundamental input resource, the sunlight. And I recognized that, and I was like, wow, sunlight is kind of everything with solar. It's not about the panels, it's not about how efficient they are or where they're built. It's all about the sunlight itself. And we need to get them more sunlight so that they can work at night. And I started looking at ways to move sunlight around on the Earth, because I saw this huge potential energy difference. And I realized the biggest potential energy difference is from space to the ground. It's kind of like a gigantic dam, where like the shadow of the Earth is, the biggest dam ever, holding back more energy than we could ever use. And all we have to do to access it is put some satellites up there and reflect some power down. And mirrors are really efficient for that. So the math works out quite well.
Well, this is a wild, literally a moonshot idea.
Yeah.
How did you go from having this idea that sounds like science fiction and then quitting your job and saying, I'm going to start a company to make this happen?
Yeah, I always knew there'd be a day that I'd start a company. So I've been training for it for a long time. I've gone through like hundreds of ideas before having this one, and I would chase them out, as far as I could go before they started seeming crazy or something like that. And I developed a really good taste for it. I also built a lot of projects.
Okay.
I worked at SpaceX, but I also did tons of projects outside of work just to kind of like build up my skills, build up my endurance.
What's your training? Are you a trained engineer?
Yeah, I have a mechanical engineering degree.
Okay.
But also I worked at SpaceX on Dragon 2 as an intern, did 2 internships there, and then worked at a couple startups after that.
Okay, so you have this idea to literally put giant mirrors in space. You had the idea. What's the next step from making that idea to actually becoming a company?
Yeah, so we raised some money.
Just on the
couple
idea
rounds.
alone?
Pretty much, yeah. I mean, there was a lot of work that went into like the pitch deck and like making sure it was clean. And I did a lot of math. I did like several months to a year and a half of mathematics on my own, just basically alone in a very small garage. And yeah, eventually, I mean, it all started working out, and I could kind of prove that everything had a reason to exist. So yeah, we've raised $8.5 million so far. And that's enough to launch a couple satellites to space. We're launching our first one in June of next year.
Wow.
Yeah, and it's going to be a fairly small one, like scaled down. It'll be a 10 by 10 satellite, a bit brighter than the moon. It'll last about as long as a solar eclipse. And we were, wondering if, we were originally planning on it just being an engineering display. So we could just use it to do calculations. We were going to do it with like, dozens of laboratories around the world and a couple of our potential solar farm customers. We're going to take measurements. And then we were like, what if we could serve a different market? Like we should see if people want to just use this for, whatever they want. It's something as a service. Who else wants it? We made a quick video, got 55 million views in just a couple weeks, and we have 182,000 applications for our sunlight.
Wow.
Yeah, as of just a couple weeks ago.
You're going to go in and raise $8 million with just a pitch deck in hand and an idea. What were you pitching? How did you sell these VCs on this?
I mean, it was a pitch deck. It was a bunch of math. It was like 50, 60 little prototypes. We also, that was across 2 rounds. So we also did a hot air balloon test with an 8-foot by 8
Yeah,
foot
I want to hear
piece
about
of
this.
Mylar.
Yeah, I'm going to hear about this, your proof of concept here.
Yeah, so we put an 8-foot by 8-foot Mylar mirror on the bottom of a hot air balloon and went out to the desert.
Like a hot air balloon that like tourists take? Or
Yeah.
Okay.
Yeah, it was a huge mirror. Like 2 big pieces of plywood, like a ping pong ball table of mirror. And then we had it on an actuated robot arm, and we could reflect that down onto a mobile solar farm. And we actually reflected sunlight down and measured the power that we delivered to these solar panels. And yeah, it was basically like 2,600x smaller scale than the satellites will be. So you can scale everything up by that amount, and it worked quite well. I mean, mirrors work. We didn't really need to prove that, but getting the Mylar surface to be actuated well and actually perform the measurement was.
How does your machine and satellites? How do they do the? I can imagine the complex calculations, the micro adjustments to A, you're hitting the sunlight, and B, you're taking like a magnifying glass and hitting a spot on the rotating Earth. Like, how does that all work?
Yeah, so the satellites themselves move in a similar way to a dirt biker. They'll rev the engine a little bit so the back wheel speeds up and that pitches them up, or they'll hit the brakes and that'll slow down the back wheel and that'll pitch the motorcycle forward. We kind of do the same thing. We just have wheels that spin up and we can rotate our satellites like this. The satellite itself is just a flat surface. So there's no focusing that the satellite is doing. It's just reflecting the light from the sun down onto the ground. It's about a 5-kilometer diameter spot on the ground. And then if you want that spot to be brighter, you just have like 2 satellites work together to provide the same brightness, or 10, 100, 1,000, however bright you want that spot to be. We can dim it and tailor it to whatever you want. And we can also move that around by just moving all the satellites.
How high, like how strong is the sunlight?
It depends on how many satellites you have working together. So one satellite could be, one small satellite, like the first demo one, will be a little bit brighter than a full moon, which is pretty dim compared to sunlight.
Yeah.
But then, once you start adding a couple hundred together, you can, get to a fifth as bright as the sun, or even brighter than that.
So you'd have 100 satellites all focused in on one focal point?
I mean, it'll never be exact. Like, it's going to be many.
Okay.
Like, it'll be dozens, hundreds, thousands, that kind of thing. But it's also, when you're talking numbers, it's really about the area that you have in space. So if you make the satellites bigger, it's less satellites. If you make the satellites smaller, it's more satellites. It just kind of depends on what rocket we're launching on, what the avionics cost, and a couple little trades like that.
Is this sunlight, this solar radiation, is it safe? Are you gonna fry people?
You can't fry people. Well, I mean, you can if you launch it like enough satellites, but we're not going to launch that many satellites.
Okay.
Yeah.
And how, if this is happening, is it gonna, if I'm on the ground, is it gonna light my, I've seen your, for solar farms, but I think you also said in your, kind of thinking blue sky, it's like, oh, like film production, or there's a Monday night football game, and instead of having all the lights, we can direct the sunlight. How far out are we from that? And also, if I'm living in that area, is it am I going to get sun pollution? Am I going to get light pollution? Is it going to seem like it's midday because your satellite's down near my house? How does that work?
Yeah, so by the end of next year, we'll be able to simulate that for 4 minutes or so.
Okay.
The year after, it'll be like a half hour or something like that. And it will be mostly lit up on the ground. You're not going to see like a beam coming down from space or anything like that. It's just going to be like a nice little warm light, like about like what street lights provide. But it's going to be a lot higher up than street lights. So, you know, my house has a street light outside the window, and it always glares in my window, and like it's kind of annoying. Our satellite is going to be directly overhead, so it's going to be, you know, actually quite nice. And like just lighting up the whole area in like very smooth general light, and it's not going to be spraying too much in the air. It's mostly just going on the ground. This is actually how you do like dark sky safe lights, or like if you're doing stadium lighting for a soccer field, you'll have like shades on it, so it just points down. We're doing a similar thing. So it's actually, you know, fairly good on light pollution. And then the light itself is just full spectrum of sunlight. So it's, you know, one of the healthier forms of light that you can have. It's not like an LED where you have a ton of like blue light, and then, you know, that makes your melatonin receptors, like it basically blocks the melatonin production. So our lights don't have as much of that as LEDs for the same comparative brightness.
Yeah, not like the blue light we have all around us.
Yeah,
right now.
Yeah, this is hard to sleep with.
How do you make money? Or how are you going to make money?
Yeah, we just offer the service. So we kind of position ourselves as a natural resources company. So we're selling sunlight as a natural resource to people. And, you know, we have figured out how to produce that. We've also figured out how to bring that to people in a way that's super fast and easy. And realistically, there's no reason you can't just get it from your phone. Like you could just text us your latitude and longitude, and we can send you some sunlight. It's only going to be like a couple $100s an hour. And, you know, that's about it. And we just need to know your coordinates and, you know that their satellite's fine overhead. So the first couple will be a little weird. You'll have to be, you know, doing something at the right time. So you have to kind of plan with us. But the year after that, like it'll be basically like, you know, anytime within this window of time, you can use the service. And then as it gets more and more, it'll be like, yeah, every single night, you know, just use it if you want to. And there'll be, you know, bigger commercial customers, like entire cities will be able to sign up for it as well and be like, yeah, we're booking like the next 10 years. And, you know, we can work with them to figure out if that makes sense. And then, you know, just get them that sunlight every single day for 10 years. Yeah.
How much or is it going to cost to launch one of these satellites?
So the first satellite we're launching is going to be $430,000 to launch. Okay. It's just like a little CubeSat guy. But then after that, like you can package it onto the rockets in a lot better way, so you can get a lot more area into space for a lot cheaper. It's kind of starting off in like the worst case, most expensive scenario, just to make sure the satellites work.
Yeah.
But then, yeah, I mean, the goal is really just get as much mirror area into space as possible. And when you're filling a rocket with these things, you can design the satellites to fit in the rocket a bit better, and you can get a lot of area into space.
So your goal is to like spend probably hundreds of millions of dollars to put these satellites in space, and then earn the money back through kind of sunlight as a service. You said like subscription model, people pay you for the hour, that sort of thing.
Yeah, and it's a bit less than hundreds of millions of dollars.
Okay.
Yeah, you can start bootstrapping it in like in the tens.
How many satellites do you want to have up there?
In the end?
Yeah.
I mean, we don't like talking numbers of satellites. We like talking about area. I mean, what we want to do is we want to make a difference in the US's energy mix, or the global energy mix. Like, you can't really get above like 30% wind and solar without the grid becoming so unreliable that, you know, it's just not worth putting any more in. And we want that to change. We want solar to be more of humans' energy, because the sun is just so good. It's just like this infinite energy source. So we could bring that 30% up to like 50 or 60%. That's really what we're shooting for. Wow. And that's the future I want to live in, where everything's powered by solar energy and it just kind of feels free to use, and you're not burning fossil fuels anymore. And we can do that with the sun. You know, the sun makes the sun in 1/5000th of a second makes more energy than humans have ever produced. So it's quite a good fuel source.
That is a stat.
Yeah.
How many employees do you have?
Oh, we're just 7 full time.
Okay.
Yeah.
Who makes your satellites?
We do. Yeah.
How you?
Almost all in house. I mean, we have a couple vendors for different parts, but we like assemble everything. We're putting it together, and then, you know, we will phase out basically all of our suppliers.
It's all in hand.
Yeah.
And what do these satellites look like? I know there's a giant mirror.
Yeah, it's like a little guy like this, and then the mirror deploys out of that.
Okay.
It's very similar to a solar sail vehicle. If you look that up, it's like tape measure booms, like 4 tape measure booms, and then they pull out this like thin reflective surface, like a potato chip bag. It's just shiny, and then thin plastic. And you just pull it really tight, and it gets super shiny and flat.
Wow.
We have a couple tricks to how we do that well, because you want that spot to be really, really sharp, so it just goes where you want it. But yeah, there's not that much to them. They're actually quite simple on the scale of satellites. They're much lighter than a Starlink satellite, which is, you know, SpaceX's telecom satellites. And they don't have the phaser antennas. They don't have to serve like dozens of customers. It's just one satellite, and we just have to move it around.
You were working at Zipline right before launching this company?
Yep.
What were you doing specifically for Zipline?
I was working as a mechanical engineer on the launcher system, which is how they launch planes into the air for Rwanda and Ghana.
Okay.
And then I met my co-founder there, Tristan.
Yeah, I've seen those videos. They're amazing.
Yeah.
When they shoot them off,
they're
dropping blood into it's insane.
Yeah.
What What was the spark that made you say, like, I'm going to leave Zipline and start this company? What was like that moment?
The seed happened when I was watching a YouTube video on the problem of solar power in Africa. And the EU was looking at spending $40 billion to build a bunch of solar farms in the Sahara Desert and then ship the power to Europe. And I was just blown away by the value of that. Like, it's worth $40 billion to bring energy from this place of high sunlight to low sunlight. And it immediately just clicked in my brain, like, oh, this is like one of the biggest gradients I've ever seen. Because throughout my life, I've done calculations on like, what if you take all the mountains and get energy from lowering them into the oceans? Like, okay, that would power humanity for like 200 years. Or like, what if you slowed the moon down, and slowed the Earth down and made a moon turbine? Like, how much energy would that produce? How long could that power humanity? I've done like all these calculations.
Again, you and I have very different hobbies.
Yeah, and I missed this one. I didn't see this one. I didn't see the sunlight gradient. Once I saw it, I just couldn't stop thinking about it. And I just stayed up till 4 a.m. for like weeks doing math. And I was originally trying to move sunlight around in vacuum tubes. I was like, I'll move the sunlight from the Sahara Desert to Europe in vacuum tubes. And it was like, $30 billion, which is still insane. But it was just the idea of moving the sunlight around. And then I realized, like, wait, moving sunlight from space to the ground is so much more leveraged. There's so much more energy availability. You don't have the nighttime thing, and you can serve places that do have the nighttime problem. So just the difference in value was insane. I had the experience from SpaceX, so I had the confidence to just, I was like, yeah, I can build a satellite. It's not gonna be that hard. Just figured everything out, started doing all the math, and it works quite well. With all the solar farms that we already have on Earth, it's already economical. We can beat the price of batteries fairly easily. And then all these other markets started developing. So there's obviously serving towns, all around the world, like Scandinavia in the winter, that kind of thing. All the wedding proposals, all that kind of more niche stuff. But then there's construction projects.
What do you mean wedding proposals?
Yeah, we got a lot of applications for people who want to propose to their spouse.
Under the sunlight?
Yeah, because you could flick the satellite on. It's like, I want to propose to the light of my life with the big light from space.
What about clouds?
Yeah, clouds are in the way sometimes. So you got to pick the right day when it's not super cloudy out. Look, for us, it's not so bad because we can move the spotlight around within a couple 100-kilometer area. But if it's not the right day in your time, we can just schedule for in the next 1 or 2 days, something like that.
Does this affect the ecosystem? Are you heating up the Earth more?
It affects an incredibly small piece of the ecosystem. And it's also not that much energy. It's basically just hitting the solar farms themselves. And when you do the calculation out of the energy added by our system versus the energy added by fossil fuels, they're we add a little bit more just direct heat. But the really important thing with fossil fuels is how much CO2 you're releasing in the atmosphere. We release almost no CO2. It's just the rocket launch, and that breaks even quite quickly. But then the long-term effects of having that CO2 in the atmosphere forever, of the just burning fossil fuels, is so much worse than what we're doing. It's way more total heat added.
Gotcha. You're obviously an expert in energy, expert in green tech. We hear so much, there's so much hype around green tech right now, so much greenwashing, all these different ideas, so much people on the spectrum saying kill all fossil fuel now versus go off fossil fuel. Where do you see, what kind of technology and systems in place that are really going to make a difference in this climate change battle?
Yeah, I think we need to use a lot more energy, and it can't come from fossil fuels. So energy use per capita in the US has basically stagnated since the 1970s. We're not using more energy, even though we live in super developed places, and we want to use more energy, we want to drive more places, we want to do more things, we want to refine more metals, but we don't really do that because it's not quite worth it.
So we're actually getting more efficient.
Maybe more efficient, maybe using less, maybe building less.
Okay.
I remember, when I was really young, I used a whole megawatt hour of electricity. My dad got pretty mad about that. And it's sometimes you just can't use less. I thought very hard about how can I use less energy? And it's no, if I want to build the stuff that I want to build, I need to use much more energy. And there's basically nothing that I can do about it. And it's there's a certain amount of iron that we want to refine. There's a certain amount of stuff that we want to ship around the world. It really affects the GDP when you can't use more energy. And we're kind of in that situation with fossil fuels where it's not so much that we can't use them, it's that it's frowned upon. It's that people don't use them enough. It's that it's not oh yeah, let's just do it. Who cares? There's social impacts, there's consequences, and that's kind of how it starts, right? So it's not just this free thing that you can use. Whereas sunlight is just this kind of free thing that you can use. I lived in a van for a while. I had solar panels on my roof. Okay. And if I wasn't using the 400 watts that it was generating, it was just kind of a waste. I might as well just make a spark and just look at it for all day. It's not a waste because it's using all that energy anyway.
You lived van life, a full van?
Oh yeah.
Why'd you do that?
I like to surf.
Okay.
Yeah, and I don't like paying rent. Yeah.
Are you still in the van?
I'm not in the van. My sister's in the van now.
All right.
I lent it to her.
You recycled it.
Yeah, she's living her surf dreams.
What do you kind of think with AI, right? And we have to talk about AI, but obviously what it can do for, controlling the energy in the grid, but then also the fact that these AI farms they're so thirsty for energy.
Yes.
Where do you see solar playing in that?
Yeah, we talked to a lot of grid operators, a lot of solar farms that are serving AI. It's pretty interesting because energy in the past has been like, a steel mill or something random that has some variability, and the grid has to keep up with that random variability. And with data centers, it's just this stable power. We need 24 hours of maximum power, and it can never drop from that. And that's what data centers demand. Like, that's what you need. And with solar, it doesn't work for that because it's like full power and then the sun goes down and it doesn't work at all. And it's like, okay, how do we fill in this? And it's like wind. Wind is like, what if it's not windy? You get all these issues, batteries, it's a big problem. So you end up burning, natural gas or, installing a nuclear power plant, which, by the way, we're not currently building new nuclear power plants in the US, so that's also a big issue, and it takes like 17 to 22 years. So we should fix those. Like, I'm very pro-nuclear, but it's not going to be immediate.
You were building them in high school, so
well, a different kind. Yes. But yeah, it's a huge problem. Like, they need this incredibly stable base load power, and ideally it would come from solar, but that doesn't work right now. So yeah, we come in and we can make solar more of a base load power.
Okay.
We'll start off not doing fully through the night. We'll start off with just like the first couple hours after the sun goes down and before the sun rises, and that makes a huge difference. You need way less batteries. But yeah, that's where we're starting, and we're going to continue to build out the constellation.
Outside of what you're building, what are kind of your big predictions for the future of energy outside of the satellites?
Yeah, I mean, energy is a hard one. It's one of those ones that has an incredibly, it's a very slow growth rate on new technology developments. Like, it's obviously huge, commercialized. Like, you talk to anybody in the energy sector and they're like, yeah, I raised like $50 billion for XYZ projects. So the growth, the building is incredibly high. I think most things are going to be powered by solar in the future. I think everybody's going to have solar on their roofs. In Australia, it's actually cheaper to have solar panels on your roof generating power than it is to have just maintenance on the power lines to your house in a lot of cases. So I think things are going to become much more local. I think things are going to become much more solar. I think solar is also a really good thing to build, in developing nations like, Africa, South America, places like that. It's really cheap and easy to build a solar farm. It's like a bit of initial investment, but once you build that thing, it makes its power back really quickly. So it's the kind of thing that you can scale up super fast. Like, you can just like stick them on the ground. You don't even have to mount it to the ground. You can just like place a panel on the ground and it starts making power. So I think solar is really the future, and it's absolutely taking off. And most new energy is a solar installation, and we're only going to amplify that. So I like throwing that in.
Yes.
But I think solar is just like going to be the future, and everything's going to be powered by solar quite soon. It's just like, yeah, if you can get rid of the nighttime thing, that's really the only thing holding it back.
Love it. Ben, thank you so much.
Thank you.